Good morning, everybody. Welcome back to Tibbetts Physics. What is crapping? In this lesson, we're going to look at parallel circuit practice problems. And just like the previous one, we're only going to look at one. In this case, you've got a parallel circuit with two resistors, R1 and R2, which is 20 ohms. And notice you have an ammeter right at the beginning of the circuit. Based on the placement of this ammeter, it's measuring the total current. Just for practice, if the ammeter were placed here below R1, it would measure the current through R1, or if it were placed right here, below 20 ohms, it would measure the current through that resistor. But, based on where it's located, it is giving us the total current. So we're going to set up our VIRP diagram, and we're going to fill it in the given information. So, they give us V total is 30 volts, I total is 2 amps, and we're also given that R2 is 20 ohms. So based on here, since we're given V and I, we could find the total resistance first. So for this, we'll find R total, and we're going to use Ohm's law. I total equals V total over R total. And if we switch the R and the I, we could solve for the R total. So we're left with R total is equal to V total over I total. 30 volts over 2 amps gives us 15 ohms. So R total is 15 ohms. Okay, let's look at a reference table to see what we know about a parallel circuit. And we could see that the voltage drop across the battery, the total voltage, is equal to V1, which is equal to V2. So V total equals V1 equals V2. So that means V1 is 30 volts and V2 is 30 volts. Alright, that was easy. Let's go back to the resistance. We know R total and we know R2, and we want to find R1. So we'll look at properties of a parallel circuit, and we have 1 over R total, or the equivalent resistance, is equal to 1 over R1 plus 1 over R2. We're solving for R1, so we'll subtract R2. 1 over R1 is equal to 1 over R total minus 1 over R2. Plug in chug. So 1 over 15 ohms, minus 1 over 20 ohms. That gives us 1 over 60 ohms. That's 1 over R1. We're trying to solve for R1. So what we do in our calculators, we'll do 1 over 60, spits out a decimal place, and then we do 1 over that number. In this case, we just get 60 ohms. So R1 is 60 ohms. I would definitely practice that in your calculator because that's the one tricky part for parallel circuits. Okay, now we know all the voltages, we know all the resistances. Let's find the currents. So step 4, back to Ohm's law. I1 is equal to V1 over R1. That equals 30 volts over 60 ohms, which is 0.5 amps. I2 is equal to V2 over R2, which is equal to 1.5 amps. And if you look at our properties, we see that I total is equal to I1 plus I2. In this case, 2 is equal to 1.5 plus 0.5. So that works out for us. Alright, last step. Calculating the power, same exact thing as a series circuit. Multiple formulas. I'm going to do P is equal to V times I. In this case, across resistor 1, V1, I1, which is equal to 30 volts times 0.5 amps, which gives us 15 watts. And if we do P2, that's V2I2, which in this case is 30 times 1.5, which gives us 45 watts. And P total is V total over, or times I total. 30 volts times 2 amps gives us 60 watts. And that's how we analyze a parallel circuit. See ya.